Okay, Saxon 4 math students, we are ready for lesson 96. It's a very important lesson. It's on averages, which is how your grades are figured. So from this point on, you'll know how your grades are figured. So let's look under the new concepts at examples. We're not going to start with grades. We're going to start with vans and passengers. Here we go. 4 vans carried the team to the soccer field. There were 5 players in the first van, 4 players in the second van, 3 players in the third van, and 8 players in the fourth van. What was the average number of players per van? So what you do, you take all the numbers that you're given and you add them up. Okay? So 5 and 4 is 9, and 9 and 3 is 12, and 12 and 8 is 20. Now what you do, you divide that among 4 vans. So 20 divided by 4 is what? It's 5, isn't it? So there are an average of 5 players in each van. It's not an exact number, it's an average, okay? Let's look at lesson practice. In 3 classrooms, there were 24, 26, and 28 children. What was the average number of children per classroom? So let's add 24, 26, and 28. I've got a combination of 10 here, plus 8 is 18, and 2, 4, 6, 7. Now how many classrooms were there? There were 3. So you take 78 students divided among 3 classrooms. How many groups of 3 could I get out of 7? 2, because 2 times 3 is 6. Subtract, bring down. How many groups of 3 could I get out of 18? 6, because 6 times 3 is 18. So there are an average of 26 students per classroom. And remember, that is an average. There were 2 stacks of books on the shelf, one with 17 books and the other with 11 books. Allison moved some books from the taller stack to the shorter stack so that the number of books in the 2 stacks were equal. When she finished, how many books were in each stack? Well, we can average this also. If we take 17 plus 11, what do we get? 28, right? Now let's divide those into 2 stacks. 28 divided in half, and you get 14 books. So we can use that same skill. Let's look at C. Spencer's scores on his first 3 games were 85, 85, and 100. What was the average of his first 3 game scores? So I know this is talking about a game, but you could think of this in terms of grades, okay? This is really going to help you. So we're going to add 85, 85, and 100. Let me add in. So here we have 5 and 5 is 10. 8 and 8 is 16, plus 1 is 17, and 1 and 1 is 2. Now, how many how many scores did he have? He had 3. So we're going to take that 270 points, divide it by 3. How many groups of 3 can we get out of 2? We can't get a group of 3 out of just 2, can we? So let's look at the next 2 digits. 27. How many groups of 3 can I get out of 27? That would be 9, right? Because 9 times 3 is 27. Subtract, bring down. We're not finished. How many groups of 3 can I get out of 0? 0, because 0 times 3 is 0. Subtract. I know I'm finished because there's nothing left to bring down. So his average score was 90. So if you had test scores of 85, 85, and 100, your grade would end up to be 90. Pretty cool, huh? Okay, let's go back and check 95 written practice. Hit pause as you check 1 through 4. Hit pause as you check 5 through 21. Hit pause as you check 22 through 27. And hit pause as you check 28 through 30. Okay, now we're going to look at the mental math section. Okay, let's do 100 times 12 and then take half of that. So we're thinking 1200, right? Now half of that would be 600. Okay, 100 times 24. Take half of that. 1200. 100 times 48. Take half of that. 2400. The salad cost $4.89. Ramona paid for it with a $10 bill. How much change should she receive? Our method for this is to count up, okay? So from $4.89 up to the next dollar level, up to $5 would be how many cents? Be 11 cents, right? And then from $5 to $10 is $5. Put it all together and you've got $5.11. The next one's really cool. The angles of the triangle measured 47 degrees, 43 degrees, and 90 degrees. What is the sum of the angle measures? And triangles are so awesome because if they just gave me two of these angles, I could always tell you the third angle. But we'll go ahead and do this first to show you what a triangle's sum of its angles always end up to be. No matter what kind of triangle it is, they always add up to this. So let's do 47, 43, and 90. Okay, here we have a set of 10. So 10. Here we have a set of 10. And 4 and 4 is 8. So we've got 180 degrees. Okay, no matter what a triangle's measures, no matter what type of triangle it is, all three angles always add up to 180. So for example, if they had given me just the 47 and the 43 and said, what is the final angle measurement? Here's what I would have done. I would have added these two. 7 and 3 is 10. 4 and 4 is 8, plus 1 is 9. And I know that all three angles have to equal 180, so I would take away these other two angle measurement totals. And 180 minus 90 is 90 degrees. So that's just a cool fact to remember, that all of the angles of any kind of triangle, if you add all three angles, it always equals 180 degrees. Okay, in 10 minutes, Tevin counted 25 cars that drove through the intersection. About how many cars might Tevin expect to count in 20 minutes? So in a set of 10 minutes, we had 25. If we double that to 20 minutes, we can double this number, and that would be 50 cars. Okay, calculation. 16 divided by 2. 8 minus 6. 2 times 2. 4. And the square root of 4 is 2. Okay, write this Roman numeral in our number system. We know X's stand for 10, and we've got 3 of them. So we're up to 30. And then single lines are ones. So we've got 3 ones. So we've got what number? 33. Okay, this one, the method that they used was kind of confusing for me, so I did a different method, but I'll show you both. It says there are 3 light switches that each control a row of lights in the room, in the classroom. A row in front, a row in the middle, and a row in back. Make a tree diagram to find the different ways the rows of lights can be turned on or off. Use the tree diagram to count the total number of combinations. So first of all, let me show you what I decided to do. I decided to make a table, and it made sense to me to show the front switch, middle switch, back switch. And one combination that we could have is on, off, right? Whoops, hang on a sec. This first combination is supposed to be all on, okay? On, on. Okay, the next combination, let's keep the first 2 on and just turn the back one off. This time, let's keep the front one on and turn the middle and the back off. And finally, let's see, we could do on, off, on. We haven't done that one yet. We could turn, let's start with the front one. We could turn it off and then leave the other two on. We could go off, off, on. These are all combinations with the front switch off here. Off, off, off. We could have them all off. Or we could jump around now and do off, on, off. And we came up with 1, 2, 3, 4, 5, 6, 7, 8 different ways. Now the tree diagram looked like this. And their reasoning was, okay, here's the front switch. If it's on, here are all the different combinations that go with it if the front switch is on. You could have the middle on and the back on. So on is a combination. On, off is a combination. On, off, on is a combination. And on, off, off is a combination. So with the front switch off, with the front switch on, there were how many different combinations? There were 4, right? Okay, that means there must also be 4 more combinations if I decide to turn the front switch off. I can go off, on, off, on, off, on, or off, off. Okay, so depending on your learning style, you may like the tree diagram and understand that, but this is what really made sense to me, and just checking to see if I had that combination yet. Okay, and we're finished.